Hi everyone. In this video, basically, I'm trying to answer a question asked by one of my subscribers based on another video which I had posted some few months back. I will share the link in the description. You can have a watch to that video. Otherwise, also, you don't need to watch that to understand this content. So, what I had discussed in that video, let me briefly explain. There is an equilateral triangle of side A, and in this triangle there are three particles. You can imagine three ants, A, B, C. Okay, now they are moving with constant speed in such a way that A always moves towards B always moves towards C, and C always moves towards A, and the speeds are constant. However, what will happen after some time is A will be here, B will be here, C will be here, right? And the condition was now A has to move towards B, B has to move towards C. Remember, C is here now, and C has to move towards A. So you will get a new equilateral triangle, but side will be different than this A. So again, when C will be here, A will be here, B will be here. So this will be your new equilateral triangle, right? And again, this A which is here will move towards this B, B will move towards C, C will move towards A. So basically what will happen is, if this is your equilateral triangle, the starting triangle, and these are the three particles at time 0, as time passes by, this particle will move in a curved path like this particle will move in a curved path like this, and this will move in a curved path like this. And they will finally spiral and meet at the centroid. So the question that is being asked is, what would be the acceleration of any one particle? We have already discussed the time taken by the particles to meet in the old video, so you can watch that. And I have also derived the equation of this path. This path, by the way, is called logarithmic spiral. So what would be the acceleration? Now sometimes students think that acceleration is rate of change of velocity, and since v is constant, they think acceleration is 0. But that is wrong, because though the speed is constant, you can see it is a curved path, so obviously direction is changing, and acceleration is vector, so it is rate of change of velocity, right? Not rate of change of speed. And the rate of change of velocity is obviously non-zero because direction of velocity keeps on changing, right? So let's try to find the acceleration. So let's say initially this was your equilateral triangle at the start at t0. Then after some time, this particle will be here, this particle will reach here, this particle will reach here, and this will be your new equilateral triangle. So this is the equilateral triangle that we need to focus, which is at time t. So this is at time t. This was at time 0. Okay. Now at time t, this is your A, B and C. So A is having velocity where? Towards B. So this is velocity of A which is directed towards B. So what will be acceleration of A particle? A particle means acceleration of particle A. That will be equals to rate of change of V vector. Now how do you write vector in terms of unit vector? Let us say here unit vector is V cap. So I can write this V bar as V times V cap, isn't it? But we know V is constant, so V can be taken out of differentiation. So this would be the acceleration. So now the question is, how do I find this? Isn't it? Well, to find this one, let me call this equation 1. Let us think of a unit vector n cap. Now you know that unit vector's magnitude cannot change, right? Its magnitude is 1. So let's say this unit vector direction has changed from here to here. This is a very small change in a very small interval of time dt. Dt here means delta t tends to 0. So in that small interval of time, this unit vector has turned here. This would be what? This would be the change in the unit vector. So this would be the small change in the unit vector. I hope you understood why this is called change in the unit vector, because from triangle law you know this vector plus this vector is this vector, right? This vector plus this vector is this vector, isn't it? So what will be b vector? C vector minus a vector. So this vector should be this final unit vector minus initial unit vector. So this represents the small change in the unit vector. D represents here a infinitesimally small change. Now what will be length of this vector? Since this is like arc of this radius, if I draw a circle here, this should be like an arc. So arc can be written as angle times radius. So this small angle I can write d theta. And what is this radius here? This length. This length is 1 because it is the length of unit vector. So the magnitude of this change in the unit vector is nothing but r, which is 1 into d theta. So if I divide the change in unit vector by the time taken, I will get 1 d theta by dt. And this, I hope you know, is the angular speed with which this line is rotating. Okay, so when something rotates angle d theta in time dt, the ratio is angular speed. So this is dn cap by dt. Of course, it's a vector, so where is the direction of this? Well, in a small interval of time, this unit vector will go here. Therefore, this change in the unit vector, which is dn cap, will be perpendicular to this n cap, isn't it? So I can write a vector like t cap. T I have used because you can call this as tangent if you call this as radius. Okay. But remember, t cap is perpendicular to this n cap. So if I apply the same technique to this equation 1, then I hope you remember this particle is turning this way. It's moving in a spiral this way, right? So your v cap, which is right initially here, right? Your v cap was initially here towards the initial position of b. So your v cap is also turning like this. Your v cap is also turning. So we can write this dv cap by dt as, here v, this v is that this v, and dv cap by dt can be written as omega times a unit vector which is perpendicular to v cap. So this is your v cap. So this can be called as t cap. So your acceleration vector, this is, remember, acceleration vector, is in what direction? Perpendicular to v bar. Remember, instantaneously, okay? Because this v bar will keep changing. Right now v bar was here, that time your acceleration was here. Okay, let me try to show this in a different page. So if this is your triangle, then initially velocity of particle A is this side, isn't it? This was your v bar. So acceleration will be along this direction. Then as time passes by, when your particles reach here, this will be the new triangle. So that time your velocity will be here, acceleration will be here. So please understand, this acceleration vector keeps on changing in direction, but it is always perpendicular to velocity vector. That is the main point. And how much we found it to be till now? So acceleration was equals to v omega in the direction of the unit vector t cap, which I have chosen perpendicular to v bar. This is your v cap. Okay. Now what is this omega? This, as I told you, is the angular speed of the unit vector v cap, right? You can check it once. Now the question is how to find the angular speed of v cap. So for that, let me draw the instantaneous triangle at time t. This was L, remember. Original distance was a. Now this is a, its velocity was v this side, and b was going with v this side. Now, as I told, this a started here like this and is rotating like this in a spiral path. Now in a small interval of time, I want to know what is the angular speed of this v cap, this vector, this v cap. So now that angular speed with which this v rotates, this v was here, remember, then it is here, then it will be here, right? So that angular speed will also be same as the angular speed with which this line will rotate, isn't it? Because when this line was here, AB, your v cap was here, correct? After that, this B will go somewhere here, A will go somewhere here. So this line will go like this, then V cap will also be here. So the angle V cap turns is the same angle this AB turns. So this line AB now becomes this line AB. This is your new AB. If you want, you can put dash, but it is just AB only, right? So the way to find the angular speed of this v cap is just to find the angular speed of this line. But remember, both the points are moving. So better you sit here and then find the angular speed. So to make the long story short, the angular speed of v cap, the angle by which v cap turns, is also the angle by which AB turns to A dash B dash. And to find that angular speed, better you do the problem from this particle's frame. Then what will be the velocity of this particle? Let us try to see. So from ground frame, particle A has velocity v this side, B has velocity this side. Let us take components of v. One along this direction and one perpendicular to this direction. Since it is equilateral, this will be 60 degree. So this will be v cos 60, v by 2. This will be v sin 60. That will be v root 3 by 2. So if you sit here, then for you B will be at rest now. A will appear to come with what speed? A was already coming with v speed. You have to reverse this velocity and add to this velocity. That is how we calculate relative velocity of A with respect to B. Velocity of A with respect to B in vector form is VA vector plus minus VB vector, isn't it? So you have to reverse VB and add with VA. Okay. So VB has velocity v root 3 by 2 here, v by 2 here. So if you reverse v by 2, it will become v by 2 that side, which will add with this v. So it will become v plus v by 2, which is 3v by 2. So this is the velocity of A with respect to B along the line joining A and B. By the way, this is the velocity which will decrease this distance. Okay. So as this line will rotate to this line, the distance will become shorter, remember, because this velocity is towards B. So this gap will decrease. That's why the particles ultimately meet, right? Okay. But I'm not interested in this speed because this speed is only decreasing the distance between A and B. You have to also reverse this velocity of b and add to a. So you will get one more velocity here. That will be how much? V root 3 by 2. Now, if you sit here instantaneously, you will see this is going in this kind of circle. So therefore, your angular speed of this line will be equals to the perpendicular velocity to this line, which is v root 3 by 2, divided by this distance AB, which is L. So this is how we calculate angular speed when two ends of the line are moving. So you sit in one of the line, you sit at one of the end of the line and then see what is the speed of the other end, which is perpendicular to this line. So if this is V perpendicular, then the omega is given by V perpendicular by this distance AB. Okay, so we got omega. So now I think acceleration you can answer. Acceleration was V times omega. So it will be V square root 3 by 2L. So this would be the acceleration of the particle. Now remember, this L keeps on decreasing, so A keeps on increasing, which makes sense also because as the particles spiral, they have to make more and more sharp turn. So with time, the sharpness of the turns keeps on increasing. So initially it may be like this, and then it has to really turn very sharp. So in order to turn very sharply, you need lot of acceleration, which is perpendicular to velocity. This is also your normal acceleration because it is perpendicular to velocity. Okay. Now in polar coordinates, you may want to write this formula in terms of r, which is distance of the particle from the origin. And normally in such problem, the origin is taken as the centroid. So let me just show you that part. So if you have an equilateral triangle and you keep your origin at the centroid and the particle A is here and this distance was L, then sometimes they may ask you to write acceleration in terms of this distance r. Then it's quite easy to find. Just drop a perpendicular to the line AB from the centroid. This angle will be obviously 30 degree, right? Half of 60 degree, and this distance will be half of this length, which is L by 2. So you can connect adjacent and hypotenuse by cos 30. So cos 30 will be L by 2 by r. Cos 30 is root 3 by 2. So root 3 by 2 L by 2r. You lose 1 2. So L equals what? Root 3 times r. So in terms of this, if you want to write your acceleration, what will be the answer? If you check the formula for acceleration, we got v square root 3 by 2L. Now L is root 3r. So root 3 gets cancelled. So v square by 2r. So this would be the acceleration in terms of r. Now I'd like to show you how to write the acceleration in terms of polar coordinates. So this would be your centroid, which we choose as origin, and normally we choose r cap this side. So I will choose r cap here. R cap means distance of the particle wherever it is instantaneously from the origin. And this is r cap, and this is what is your theta cap. Now remember, your particle's velocity is this way. So this was your velocity of the particle, which was your v cap. And acceleration was in what direction? Perpendicular to this velocity, isn't it? So it was perpendicular to this velocity, means it was here. So this was your acceleration and this was 90. Now you know this angle is 30. And therefore you can divide this acceleration into one component here, which is parallel to theta cap, which is again theta cap is perpendicular to r cap. In polar coordinates, this is how we take unit vectors. So this is parallel to theta cap and this is parallel to r cap. Now this angle will be how much? If this is 30, this is also 30. Why? Because this line is perpendicular to this line r cap, and this line are perpendicular, and this is v, and this is your acceleration. So those two are also perpendicular. And million times I have told in my class that if two lines are at angle theta, the perpendiculars are also at angle theta. This is what I call ancient Greek rule, because this was known to ancients also. So you should obviously know. So this is A. So this will be what? A cos 30, and that is your acceleration along theta cap, and that is your tangential acceleration. Tangential. Okay. So tangential acceleration will be A cos 30. A value already I have told you, substitute and get yourself. And radial acceleration means along this one, and that will be your A sine 30, isn't it? So radial acceleration will be A sine 30, right? So this would be, if I show you, A was v square by 2r, cos 30 is root 3 by 2, and v square by 2r sine 30 is half. So this is your radial acceleration, this is your tangential acceleration. Okay.